Configure iBGP between the hub and all the spokes. Use the DMVPN tunnels. Each spoke may have only one BGP neighbor. All spokes must have the loopback networks for the other spokes. Do not add static routes. Do not configure alternate routing protocols. Let's start with the hub. We must use the DMVPN tunnels. The IPs on the tunnels is 192.168.1 and the last octet being the spoke ID. Add the neighbor statements. With the spokes, the loopback networks must be advertised. All the loopbacks follow the pattern of 10.1 and spoke ID. On each spoke, configure the hub as the neighbor and advertise the loopback. Return to the hub and check the peerings. They are all established. I know this because there is a number value here. Any number value, including 0, signifies the peering is established. The hub currently doesn't have any routes from spoke 3 and spoke 4. Refreshing shows now that a prefix has been received from each spoke. The hub's BGP table shows the received prefixes. Go to spoke 2 and verify that it has the prefix for the other spokes. It does not, and this is to be expected. Spoke 2 has not received prefixes from the hub. On the hub, you can see that it isn't advertising the prefixes to spoke 2. The same would be true for spokes 3 and 4. Recall that iBGP peers do not advertise prefixes learned from one iBGP peer to another. The reason being that the autonomous system path attribute, BGP's loop prevention mechanism, isn't applied when advertising to iBGP peers. Then how can we ensure all spokes receive all prefixes without a full mesh peering? The answer is a route reflector. The hub, having sessions with all the spokes, would serve as the route reflector. As a route reflector, the hub can advertise routes learned from the iBGP peer to another. Routers that pair with a route reflector are unaware that they are route reflector clients. This is because the necessary configuration is applied on the route reflector. On the hub, under the BGP process, for each neighbor, add the command neighbor IP route reflector client. The hub is now advertising the prefixes to spoke 2. The prefixes appear in spoke 2's BGP table. Take a look at spoke 3's prefix and the information included. The prefix is from spoke 3, but was received from the hub. Again, the originator is spoke 3. The cluster ID will be addressed in later videos.